Hi everyone. In the previous video we have studied the triangle law of vector addition, and we have seen several simulations which were telling you how can I practice the triangle law of vector addition and to find the resultant of two vectors. In fact, I have also shown how can I use three vectors getting added up. And as said earlier, today in this particular video we are going to talk about you see the other law, that is parallelogram law of vector addition. This also happens to be one of the fundamental laws of vector addition, and I would also tell you or maybe show you by some animations or simulations that this parallelogram law of vector addition seems to be like a parallelogram law itself, or it can also be understood like your triangle law of vector addition. So first of all, let me understand in which situation can I use parallelogram law of vector addition. That if at all I have two vectors acting at a certain point which are of the same type, so either two forces or two you can say accelerations acting at a certain point, then in that particular case, if they are having certain angle between them, how can I find what is the resultant of the two vectors? First of all, I will go for what is the statement of this particular parallelogram law of vector addition. It says that if at all I have two vectors of the same type which are represented in magnitude and direction by two adjacent sides of a parallelogram, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram in magnitude and direction starting from the same point. The diagram will be able to show us this in a better way. I have got two vectors. One is shown here in this figure with vector A here. The other is vector B shown by red vector. And then I say that if at all I have two vectors, vector A and vector B, acting at the same point, and if I want to find what is the resultant vector A plus vector B, then I simply have to complete this parallelogram, and the diagonal which starts from the same point where A and B vectors were acting, that particular diagonal will represent in magnitude and direction the resultant of those two vectors. That is what it says. Now I have another diagram here which shows that I have got two forces. One is force F1 here, the other is force F2 here. Both forces are acting at this particular given point. And then if I want to find what is the resultant, see, it's basically obvious that if at all some force is acting in this direction, the other force is acting in this direction, the resultant of these two forces has to act somewhere in between those two. But where exactly? What is the angle made? What is the elevation made by that resultant vector? And what is the magnitude of that? It is actually given by the parallelogram law of vector addition, the proof of which we will be doing a bit later. But before that, here once again I say that if at all F1 and F2 they were acting, I just have to complete a parallelogram, the two adjacent sides of which are F1 here and F2 here. So once I complete this parallelogram, then the vector which starts from the common point, or the diagonal which starts from the same common point where F1 and F2 were acting, that would give me the resultant vector of F1 and F2, or it will give me the vector addition of F1 and F2. Now this can be once again better understood by some kind of graphical representation, which I will go for here. Here in this I can see that I have got you can say two vectors. One is vector A here, the other is vector B here, and their addition will be considered to be some other vector called as vector C. What is this vector exactly? So I have specifically chosen this vector to be somewhat you can say elevated with respect to x-axis, and vector B I have chosen horizontal, such that if at all I want to understand what are the equations of vector A and vector B, I can say that this vector A is actually let us say 6i cap plus 8j cap. So this is 6, 1, 2, 3, 4, 5, 6. So 6i plus 8j, that is this particular vector. And this vector B is simply of magnitude equal to 10. From here to here I can say it is equal to 10. Or rather I can say in terms of vector it is equal to 10i. If at all I want to add these two vectors, as I say that these two vectors are randomly placed, and if at all I want to use my triangle law, parallelogram law of vector addition and try to find what is the resultant of these two, as the parallelogram law is stating that the two vectors have to act at the same point. So I'll bring my vector A to some point here. Parallel vectors of the equal magnitude are equal, so A is just brought here, vector B is brought here, and then I have to complete a parallelogram. So if I complete a parallelogram, the two adjacent sides of which are A and B, then the vector starting or the diagonal starting from A and reaching till the other end, that would give me in magnitude and direction the resultant. Now let me try and just find out if I find what is the resultant of those two. So this resultant happens to be your vector C. Now whether this resultant which this graph or this simulation has shown, is it exactly the diagonal of that? Let me just try and see. So what I just do is, I'll just bring it to this point. Okay. So if at all I complete a parallelogram, now let me just do that here. I have got two other duplicate vectors of them, that this is vector B, the parallel, in case of parallelogram, the opposite sides are parallel and equal. So this vector A will have its opposite side which is replica of that. So it is here, and this vector B is going to have it somewhere here. So then I have got this parallelogram is completed, and then I find that vector A plus vector B is given by this diagonal vector C, and that actually tells you what is your you can say parallelogram law of vector addition. Now whether this is right, I can just check by its you can say I have got vector Ax given by here. If I say in this particular case that vector Ax is 6i plus 8j and vector B is given by 10i plus 0j. So if I add them, I and I will get added up. So Ax here and Bx, they will get added up. It has to be 16i cap. This has to be 16i cap, the resultant C. And this Ay plus By is going to be 8j cap. So this resultant vector over here, this C, this must have its vector representation as, it must be 16i plus 8j. Now let me just check if it is 16i plus 8j here, and then I find it is 16 here and 8 here. So it is 16i plus 8j. That is what you have. Now how much is A and B, we already know. So I'll just take this off again. Now what I further find is, I was saying that triangle law of vector addition is somewhat similar to your parallelogram law is somewhat similar to your triangle law. How can I exactly understand that? As I know that the C is the addition of A and B, or the resultant of A and B, and that's obtained by using parallelogram law. If I want to understand this particular thing as the triangle law of vector addition, the triangle law just tells me that you have to take vectors in such a particular way that wherever your first vector ends, the other vector has to start. So I'll just lift this B and take it at the end of vector A. So this B is lifted up and it is taken somewhere here, and then I find vector A plus vector B is equal to vector C, I find. Whereas if you even want to find what is B plus A, it is also possible. I'll take this, lift this B, take it somewhere here. So this is vector B. Then I'll take this vector A somewhere here, that is at the end of B, and then I'll find that B plus A is also equal to C. So either I use triangle law of vector addition or I use parallelogram law of vector addition. The vector addition should not change. So once again, even this particular condition of the triangle law or even parallelogram law, they are basically proving that the vector addition is commutative as well. So in this particular case, what is its magnitude given by? The magnitude is given by one more formula, which the proof of which we will be just doing in the next lecture possibly. But this is what we have seen. Now instead of this, what I just do is I take you can say some other vectors. I'll just remove these vectors, and I'll take my vector A to be something like say 10i plus 8j, and vector B, instead of horizontal, let it be slant in the downward direction going down. Maybe I put it somewhat like this. So vector A is acting here, vector B is acting here. In this case, if I once again want to find the addition of these two, I just have to have these two vectors acting at the same point. Let me choose that same point over here. And vector B is also brought here at this particular point. Then this is A, this is B. I then have to complete a parallelogram with the adjacent sides as vector A and vector B, and their diagonal starting from the same common point of A and B will give me in magnitude and direction the resultant of these two. So what is the sum of these two vectors? What is the resultant of these two? It's given by C. Now is it after forming the, you see, parallelogram, I can just see here that vector A, I'll just bring it here. I complete this parallelogram, and by completing the parallelogram, I once again find that parallelogram law, it tells you whatever sum we have obtained by using the simulation is also matching as per the parallelogram law statement. Moreover, what I find here is these vector additions would always be very simple. Like whenever it is represented in the xi plus yj format. So vector A will be taken as axi plus ayj, that is 10i plus 8j, it will be 10i plus 8j. Vector B will be represented by 10i minus 4j. So that is what you have, 10i minus 4j. And then in that particular case, okay, this is 10 plus 6, let me take it as whatever. Then in this case, I will observe that ax and bx, if at all they are added, that gives me 20. 6 minus 4 will give me 2. So it's going to be 20i plus 2j is supposed to be this resultant B. Now let me just check whether this C is having those particular things. So it is 20 along x-axis and 2 along y-axis. So it is 20i plus 2j. That is what I can find here. So that was about the parallelogram law of vector addition, and the mathematical proof to find the resultant, its magnitude, it can be you can say done. That proof of parallelogram law is an extremely important proof, which time is not permitting in this particular video. In the next video, we will see how can you find the magnitude of the resultant vector just by using the formula. Here in this simulation, it was easily possible for me to take certain ax, bx, ay, by values, and its addition was proved fantastically to be correct as per the parallelogram law of vector addition. Now, if at all A and B, only their magnitudes are known, and if at all the angle between A and B is known, how can I find the magnitude of C? That is what is the next task of ours, and that is what we will be seeing in the next video. So once again, thanks for watching this video. See it multiple times. Try to write these things, note these things down, and then it will help you to understand things better. Thank you very much.